Hassler here. I was just going to give you some hints to help you through this 4.3 first derivative test practice number 3. We had discussed yesterday in class on the practice number 2 how to use the graphs of f prime in order to answer some of these questions. And so we've been talking algebraically how to determine critical values for f by finding when f prime of x equals 0. Again, on the practice number 2, we discussed how to use the graphs of f prime to again identify when f prime of x equals 0, indicating when f has a relative min or max. And so I just want to go through some hints. Again, I'm not doing these problems for you. Your job is to complete these problems, but I'm going to write some hints as I go down on this document. And if you want to copy those hints down, I advise it on a separate sheet of paper. So it says use the graph of f prime. And again, notice you have f prime labeled for the graph to complete the following. So find all x values for which f, I don't have the graph of f, I have f prime, but I want to know where f has a relative minimum. And remember, f has a relative minimum when the critical values, or where f prime of x equals 0, changes from negative to positive. In other words, I have a relative min when the slopes of my tangent lines to f, so this is my graph of f, when the slopes of my tangent lines change from negative slopes to positive slopes, and that's what the sign chart shows us, okay? So again, you have to identify critical values for f. I'm going to abbreviate. That occurs when f prime of x equals 0, and we're real lucky because look, I have f prime of x, and I should be able to pick out where f prime of x equals 0. There's one of those at x equals negative 3, etc. Since it asks for a relative min, again, I'm looking for when f prime of x changes from negative to positive, and I'm going to justify, and justify means that you state what. I'm going to answer the question, a relative min, where and why. Like, how do you know that's happening? All right, B says list all the intervals, and those are intervals of x values. Anytime it's asking for an interval, you're always stating x values, and you can use inequality notation or interval notation with parentheses. You will see that my answer keys typically use that interval notation. Okay, where f of x increases. We talked about the fact that f of x increases when f prime of x, slopes of the tangent lines, are positive. And so I'm going to use this key idea. I'm going to use the graph of f prime to help me answer that question. Justify, again, means that you need to make a statement. You need to make a statement of f of x is increasing. That's the what. Where, so what x value is that occurring at? And here is the y, because f prime of x is positive. Okay, 2 states, let f prime of x equal, man, this looks familiar, huh? Determine all the intervals in which f of x is decreasing. And so, again, this has this g notation in here. So this is f prime already, where g is greater than 0. And when we're talking about g being greater than 0, that means that g of x is positive. And g of x is right here in that f prime, in which f of x is decreasing. Well, up above we said f is increasing when the slopes of the tangent lines are positive. So similarly, I could say f of x is decreasing when the slopes of the tangent lines, f prime of x, are negative. And so the first thing that I would do is I would identify critical values. Remember, that's where f prime of x equals 0 or does not exist. I'll have a polynomial function, so my derivative will exist, okay? And then I'm going to make a sign chart for f prime of x, okay? I don't have a graph here. I think the graphs are easier because it's already laid out for you. In this case, you have to do a little bit of work, okay? And then you're going to make a statement to justify. And that statement should include the what. The what is that f of x is decreasing. The where, and that's going to be intervals. When we talk about increasing and decreasing, we're looking at intervals. And the why. Why is that happening, or how do you know? And this right here would be the why. Because the slopes of the tangent lines are negative, or because f prime of x is less than 0. Okay? And the last problem on this document, it says, consider the differentiable function f having domain all positive real numbers, and for which it is known that f prime of x, I'm going to highlight this, f prime of x is equal to 4 minus x, that quantity, times x to the negative 3. Whew, okay? For, again, all values of x greater than 0. Okay? It says, find the x coordinate of the critical point of f. Determine whether the point is a relative maximum, minimum, or neither, and justify your answer. Okay, again, I'm given f prime of x, and I need to determine when f prime of x equals 0, or when f prime of x, okay, does not exist. Okay, and then I need to create a sign chart. I feel like I'm on repeat here, right? Find the critical values when f prime of x equals 0, when f prime of x does not exist. Create a sign chart for f prime of x, okay? And then you need to classify that critical value. And that means that you're going to state the what. What is it? Is it a relative min, max, or neither? Where? What's the x value that this is happening at? And why, or how do you know? Okay, and again, that goes along with the whole idea that f prime of x changes from positive to negative for a max, or f prime of x changes from negative to positive for a min. The other idea to keep in mind as you're working is this right here. All x values are going to be greater than 0. So when you make this sign chart, it's like your sign chart for f prime of x is starting at 0. Okay? All right, if you have any questions, be ready to ask me. Next week, you do have a short quiz on 4.3. If I were you, though, I would actually just email me questions or send me a message in Google Classroom, so you're not waiting until the day of the quiz. All right, have a good one.